4.5 Graphing Linear Equations, Algebra 1. Want to give a shout out to my Algebra 1 students at Hidden Valley High School. You rock. Okay, so let's rock this section and the next one too. In this section, we're going to do solving for y, which we've practiced a lot, and now you know why we have to do it. So you're going to have to solve for y in order to graph or graph using the x and y intercepts from the standard form. We're going to learn how to do both today. All right, so the first thing, you need to know what a linear equation is. Now notice how the word linear has L-I-N-E, line in it. Okay, that means it is an equation of a line. Linear means line. Standard form of an equation is this form right here, ax plus by equals c. Now this is important. You'll use this down the road and several things we're going to be doing. But you need to remember, standard form is ax plus by equals c. These forms and formulas that we're going to be working with, these are all stuff that you have to memorize. They will not be on your formula sheets. So you need to remember that, that this is standard form, ax plus by equals c. So your x and y term needs to be on this side and c on this side if we need it in this format. All right, so now rules for linear equations. First thing you want to do is solve for y. Yay, we can do this. All right, the next one is that you want to make a table, and you're going to pick 5 values for your domain, and you want to pick easy numbers. You don't want to pick 10. That's way too big. You want to pick small numbers like -1, 0, 1, 2, -2, those kind of things. Small numbers. And find the corresponding range value by plugging into the equation. And you'll see what I mean when we start doing these. Then you're going to plot those points on the graph and draw a line through those points. And then you're going to check your graph by using your calculator. So this is when you really, if you don't have one, you need to have some way of accessing a graphing calculator. Most of your computers have one. Come see me if you do not. Is the equation linear? This is going to be one of the questions in the way they could ask you about these kind of things. Is it linear? Now how you know that is you can do one of a couple things. You can solve for y and graph it in the calculator and then see if it's a straight line, or you can make a table and see how the points line up and then graph those points. I think it's easiest to solve it for y and graph it in your calculator. So looking at this one right here, if you had y equals 5 minus 2x. Now watch what I'm going to do. I'm going to pull up my calculator. Now my calculator on my computer doesn't do every single thing that the actual ones do, but it works pretty good. All right, let me move this out of the way. All right, so this is going to be y equals 5 minus 2x. Now notice we have a y equals button on our calculator. And many of you have pushed that button by accident in class. And now you're going to use it. So you're going to push y equals, and you'll see that it comes up with y equals. So what you do, you don't have to type y equals in your calculator. You just have to type in the rest of it. So this is going to be 5 minus. All right, now notice it says 2x. Here's your 2, but your x button is right here. It says x, t, theta, and n. Okay, right here is your x button. You'll use it for all your x's. Okay, so you push that button. Now notice I have 5 minus 2x, and that's what my equation is. And then you want to push the button that says graph, which is right here. And we're going to be very familiar with this in this section. The graph. Now this is in the standard window, but if for some reason you come in after one of my other classes and they've changed the window, you want to hit zoom 6 to put it in standard window. But this one is a standard 10 by 10 grid. Okay, so now you notice that this makes a straight line. So yes, y equals 5 minus 2x is linear. So I'm going to put yes right here. Okay. Something else that you can notice, the x term, oops, get my pen to work, the x term right here is, there's no little exponent with it. If there's no little exponent, it should be linear, unless it's one of the special cases, which I'm going to show you. Okay, so this is a yes. All right, the next one, we need to solve it for y in order to put it in our calculator. So I'm going to, remember I told you when we're solving for y, x has to go first, like in the alphabet. X got to go first. So I'm going to subtract 2x from both sides. And remember I told you I want you to start putting the x term first, and you'll see why very soon. Negative 5y equals negative 2x plus 6. And then we divide everything, what's it negative? By 5, negative 5, everything. This is where if you didn't split it up, now it's going to get you really bad because it needs to be all split up. So this one is going to be y is equal, negative 2 divided by negative 5 makes a positive 2/5. X doesn't look like a very good 5 right there. 2/5 x, and then it's going to be 6 divided by negative 5, which just makes a negative 6 divided by 5. Okay, notice my x term doesn't have a little exponent, so it's probably going to be linear, but let's check my calculator. All right, so bring that back up, move it out of the way so I can see what I've got. Yeah. Let's move this down. Bring the calculator back up. Move this back up so I can move it. Maybe not. There you go. All right, so I want to go back to y equals and type this in. So if you want to clear that out, hit the clear button and it'll all go away. So now I've got 2 divided by 5, and I have the x up here, and the minus 6 divided by 5. Okay, make sure you typed it in right and double check what you've got. Right, then you hit graph. Now you notice this little cursor thing up here, when it stops moving, when it's not up there, then that means it's finished graphing. All right, so this one is, again, another straight line, so the answer to that one would be yes. This one is, whoops, got on the wrong thing again. This will be, yes, it is linear. All right, and then the last one, we need to solve it for y, so I'm going to subtract x squared from both sides. So negative 3y is equal to negative x squared plus 6, and divide everything by negative 3. This one's going to simplify. Let me put it up here where you can see it. Y is equal to positive 1/3 x squared. It's a negative divided by negative is positive, and a negative and a negative 2. All right, so when we graph that, let's go to our graphing calculator and type that in. All right, so that's going to be 1/3 x squared. Here's your square button. Remember we used that before. Minus 2. Now the other thing, I want to just clear that out, hit delete. And so now I have 1/3 x squared minus 2. Well, let's look what that looks like. Wow. Is that a line? No, that is not a line. So this would be not linear. So you notice that we have a x term with an exponent. So if you have an x term with an exponent, it will not be linear. Okay? All right, next page. All right, so now we want to graph y is equal to 2x. And we're going to start with a table, and we'll get our points, and then we'll graph the line. Okay, so I'm going to start with negative 2, and then I'll go negative 1, 0, 1, and 2. So what I'm going to do, those are just numbers I picked that I think are easiest. You don't have to use those, but I recommend that you try using these because they will make the smaller numbers so that you can fit them on your graph. And then you're just going to take this x and you're going to plug them in right here. So 2 times -2, which just makes -4. -1 times 2, which makes -2. 0 times 2, well, that's 0. 1 times 2, 2, and 2 times 2, 4. So that's a very easy way of getting your ordered pairs, okay? So then you're going to go up here and graph, and we practiced this in class last week. It's going to be a -2 and go down 1, 2, 3, 4. -1, -2, 0, 0. Remember, that's our origin. 1, 2, and 2, 4. Right? So, and then you want to connect your dots with a line. Okay? So the question was, is this linear? And yes, it made a straight line. So yes, this is linear. All right, so the next one we have to solve for y, because you can notice it's not that way. So we have to go ahead and solve it by subtracting 2x from both sides. So this will make -y over here. This just cancels. And then -2x plus 6. Now, I'm not done because there's a negative in front of that y. We have to get rid of that by dividing everything by -1 or just changing all your signs. Either way, it works the same. -1, -1, -1. So this becomes y is equal to 2x minus 6. Okay? So, again, I'm going to use the same points. -2, -1, 0, 1, and 2. Okay? And then I'm going to take these points and plug them in right there for your x value. So it's 2 times -2, 2 times -2, which is -4. -4 minus 6. -4 minus 6 is going to make a -10. And we may not have enough room on there to do this. All right, so -1 goes in here times 2 makes a -2. -2 minus 6 is going to be a -8. 0 times 2, which is 0. 0 minus 6 is -6. And then 1 times 2 is 2. 2 minus 6 is -4. And then 2 times 2 is 4. 4 minus 6 is going to be -2. Okay, so there's our new ordered pairs. So every time you plug it in, it's going to be different things because you have a different equation. All right, so then you come over here, and we may or may not be able to graph it all on here. -2, and then I have to go down 1, 2, 3, 4, 5, 6, 7, 8, 9, down here somewhere. -1, 8, 1, 2, 3, 4, 5, 6, 7, about right there. Oops. Okay. 0, -6 is going to be 1, 2, 3, 4, 5, 6. 1, -4. 1, 2, 3, 4. And 2, -2. 1, 2. And draw your line. And the question was, is this linear? And again, yes. And another way you can double check, my x value does not have a little exponent there, so that's good. Just like this one up here did not have an exponent up there, so that means that it was good too. Okay? Next slide. All right, intercepts of equations. we have two kinds. One's the x-intercept and one is the y. The x-intercept is the point where the function crosses the x-axis. The y-intercept is where the function crosses the y-axis. Best time to graph a line using those x and y intercepts is if the line is in this kind of format, ax plus by equals c. It's very easy to use from there. And since you only need 2 points to make a line, if you have the x-intercept and the y-intercept, you've got your line. So to find the x-intercept, you cover up the y term and solve it for x. Remember, the intercept will be a location, so you must be writing it as an ordered pair. So you have an x value, whatever you find, and then 0. Same thing with the y-intercept. You cover up the x and solve for y. Again, you have to have an ordered pair as your answer. So this time it'll be 0, and then your y term you find. So watch what we do with these. All right, so we have 3x plus 2y equals 9. And we want to find the x and y intercepts. All right, so if I cover up my x term and pretend it's just not there, okay? Pretend it's not there. You just have 2y equals 9. So then you just solve for y. So y is going to be a fraction, 9 over 2. Okay, so now, you come over here and clean this off. Because now I'm going to solve for x. So when I do that, I'm going to pretend that this y is gone. Because if you plug in a 0 for that, it's basically what you're doing. It makes it go away. So now I just have 3x equals 9. 3x equals 9. Divide by 3. So x will equal 3. But I have to have ordered pairs. So remember, x comes before y in an ordered pair. So this would be 3, 0. And my ordered pair for my y would be 0, 9 halves. Now, you've got two ordered pairs you can go and graph. So I'm going to go over here to 3, 0 and put a dot. And then I'm going to go up here to 0, 9 halves. 9 halves is the same thing as 4 1/2. So it's 1, 2, 3. Let's see, 1, 2, 3, 4, and in between there. Right? And then you just connect your dots. There you go. All right, let's try this one. All right, I'm going to cover up the x one first, and so that leaves me with just 3y equals 12. So I'm going to divide by 3. So y is going to be 4. But I'm going to go ahead and make it into an ordered pair. So remember, if y is 4, that means the x is 0. Okay? And then I'm going to do the same thing with my x. So I'm going to erase this so I can see what I've got. And I'm going to mark out the y. So now this one is going to be 4x equals 12. And that makes x to be, if you divide by 4, 3. So then remember it's an ordered pair and the x comes first. So that's 3, 0 again. So I'm going to go over here and put a dot on 3, 0. And a dot on 1, 2, 3, 4. Which is almost the same exact line, just a little bit different. And draw your line. It's that simple. So if you want to find the x-intercept, cover up the y. If you want to find the y-intercept, you cover up the x and solve for the very little simple problem, and then you graph those points. Okay? All right, so let's determine the x and y intercepts of each of these functions. So we want to see where it crosses the x-axis and where does it cross the y. So I'm looking right across here, and right there is the x-intercept. What point is that? 1, 2, 3, 4. So it's x is 4. That means y is 0. All right, let's find this one. Go right up here, and there's where it crosses the y. So that point location is going to be 0, 2. Okay? Let's look at the next one. Right here is where it crosses the x. right here is where it crosses the y. So that point right here is the negative section, so it's going to be -2, and the y is 0. And then the y-intercept, the x will be 0, and it's going to be 1, 2, 3, 4, -4. Right, in this one, there's my intercept, there is my intercept, and let's figure out what the x one is. It's at -1, 0, and then for my y, it would start at 0 and go up 1, 2, 3, 4. And there you go. Very simple to find them. The tricky part is when you're doing these kind of problems to read the instructions to see what they're asking you for. Lots of things in this chapter to ask you about. This one's just asking about x and y intercepts. Okay, so be very careful and read your questions. All right, horizontal and vertical lines. Remember we talked about horizontal, the horizon. Okay, think of the sun on the horizon. Okay, the horizon is going this way. So we want to draw a horizontal line anywhere on our graph. Oops. All right. Now it says, does it have an x-intercept? Does it cross the x-axis? Well, my x-axis is right here. Does it ever cross? No. No, it does not, because it never crosses x-axis. Okay, so we need to write an equation for this. All right, so if I was going to give this an equation, where is it crossing right here? What's that point right there? That's up to on the y. So that would mean that y is equal to, we don't have an x, so we won't have an x in our equation. Y is simply just equal to 2. There's no x, it's just a y, and it's saying that it goes right across here at 2. All right, now we need to draw, let's change my color, a vertical line. Vertical means up and down. Okay, does it have a y-intercept? So I'm going to come over here and draw a vertical line through here. Okay, all right, so my vertical line goes through point 1, 2, 3 right there. All right, does it have a y-intercept? This blue line, does it have a y-intercept? No, and because it never crosses the y-axis. Whoops. Okay, it never crosses the y-axis, so it cannot have a y-intercept. Now, what would the equation be here? Okay, I'm only on the x, right? Okay, so that's saying x is 3. That is the entire equation, and x equals 3. There's no y in my equation because there's no y involved with this line. So a vertical line will only be an x equals problem. A horizontal line will just be a y equals problem. And then a linear equation like we've been doing, where it has both x and a y value, will be a diagonal line. Okay? It's very important that you remember the difference between the horizontal and the vertical equations and be able to graph them. Okay? And that's it for this time. Hope to see you in class, and study hard. We've got lots to do.